Hey, welcome back guys. In this video I'm going to be installing a 2-color status light in my Crybaby. In the last video I put a little DC to DC boost converter in my Crybaby because it's an old 18 volt model. So now I can use a regular 9 volt supply and the pedal gets 18 volts. The trouble is these little modules are also kind of voltage regulators, so if I use a battery the pedal sees a constant 18 volts until the battery is completely dead, then just suddenly switches off. So what I want is a status LED that also sheds a little bit of light on the condition of the battery. With most pedals these days, they use one of these things. It's a 3-pole stomp switch. 2 poles are for true bypass, and the third is just used to switch the LED status light on and off. The 535Q is already true bypass, but it's only got this double pole switch because it doesn't come with a status light. So the first thing I'm going to do is replace the double pole switch with this 3-pole switch. Now, obviously the footprint of my new switch is very different from the old switch, and I guess I could just work out where all these wires go, cut the wires, and just solder them directly to the appropriate lugs on the new switch. I'd have to lengthen them all though, it'd be a bit fiddly. I could just design a new circuit board for the new switch and then reuse this connector. This arrangement here is a standard size connector. They're called header pins. But instead, I think what I'm going to do is I'm going to try and desolder this switch and then reuse this little board on my new switch, but just with some lengths of hookup wire. Now, I've got this cheap little desolder pump. You've probably seen me use it in other videos, and they work okay, but when I've got large lugs like this with a lot of solder on them, and also on boards with what they call plated through holes, this is a double-sided board, you need something with a bit more power, and that's where I use this guy. This is called a solder pult. You can buy these on Amazon. They're not actually that expensive. Sometimes you have to go round a few times. If you don't get all the solder in one go, don't just keep reheating the same lug, move on to the others. That way you run less risk of damaging the part or the board. But yeah, the solder pult works really well. And there we go. I'm just going to have a look at this board under my magnifier and make sure it's okay. It's got a fair bit of flux on it, but those tracks look fine. So there's my new 3-pole switch mounted on the old circuit board. This lower right hand lug is actually connected to earth, so I've also connected the middle lug of the spare pole to that same piece of hookup wire, because the status LED will switch to earth to light up. For what it's worth, I could have actually left the original 2-pole switch in there and still had true bypass plus a status light. There is a way of doing this. I think it was done back in the 80s by Proco with a rat pedal. And then about 20 years ago, R.G. Keane, who's quite well known in the DIY music electronics world, refined the idea with what he called the Millennium Bypass. Pretty sure you can still see that article on his website. The circuit uses the earthing resistor on the output coupling cap to operate a transistor, which switches the LED on and off. But really, these days, 3-pole stomp switches are easy to find. You can buy them out of Shenzhen for like $2 each. Here in Australia, you can even buy them at JCar, I think Altronics as well. There is another reason though why I changed out the switch here, and that's because in a wah-wah pedal, or certainly a Crybaby wah-wah pedal, the stomp switch actually gets a pretty hard life. These contacts don't actually latch until the switch is almost all the way down. So in normal, wah-wah operation, even though you aren't actually switching the switch, you're constantly pushing it in and out to about 2/3 of its travel. And even though this switch still works okay, it is pretty shagged. I don't know if you can see how much wobbly movement there is. So I may as well switch it out while I've got the pedal on the bench. So this is a fairly standard arrangement for an LED in a pedal build or whatever. You've got the cathode connected to earth, or probably switching to earth with your stomp switch, and then the anode is connected to the 9-volt supply. This is a totally bog standard, cheap and cheerful 5mm red LED, and with a 2.2 k ohm resistor, if I switch on the 9-volt supply, it's nice and bright, and that's typically what you'd use for a pedal build or whatever. If I start lowering this supply, because that's what happens when a battery starts wearing out. If I go to 8 volts, 7, 6, 5, 4, well, around about 5 or 4 volts, it's noticeably dimmer. But of course, by that stage, your battery is knackered, and really it's sort of too late to know about it. So this simple arrangement can be improved. What the clever engineers at Boss did back in the, I guess 80s, when they were designing all those classic pedals, they added this guy, a Zener Diode. This is 4.7 volts, but typically they use 5 or 5.5 volts, around about that range. This is just the closest thing I had. But it'll be fine to demonstrate. And what this does, if you add it into this same circuit, you can have these 3 components in any order really. But what this Zener Diode does, it sort of exaggerates that dimming effect and makes it happen at a much higher voltage. So there's 8 volts, there's 7, and certainly by 7 or 6 volts, it's the LED is really, really dim. And this really makes a nice addition to your pedal builds or whatever, or it could be a mod you might want to add, because it will give you, to a certain extent, some indication of the battery's condition. If the battery is 6 or 6.5, 7 volts, you'll probably still get through the gig, depending on the battery and the pedal, of course. But you do need to change the battery. It's not urgent, but you should change it. What I want for my Crybaby pedal, however, is something a little bit more sophisticated. I want to use a 2-coloured LED like this guy with 3 legs, and have it switch from green to red just as the battery gets at that critical 7.5 volt range. So here's a little circuit I put together to hopefully do just that. This, well, honestly, you can do this a number of different ways, but I've chosen to use a dual op amp here, because if you're anything like me and you like to build pedals as a hobby, or preamps, and you mess around with audio electronics, then you've probably got a whole drawer full of old op amps. And I've just gone through this and found the lowest current op amp that I have, and in this case I think it's a TL062 or something like that. Honestly, there's hundreds of op amps that will do this. You really just want something that has a very low current draw. It has no bearing on the sound of your pedals, so you just want it to use as little current as possible. These are wired as comparators, and I think the first time I used an op amp as a comparator, I think it really helped me understand how op amps actually work and how they do what they do. So I would encourage you, if you're kind of still learning this stuff, to breadboard this circuit and play around with it. A comparator simply compares its two inputs, and if the voltage on the, say, the inverting input is lower than the voltage at the non-inverting input, then the output of the op amp swings high, and, well, vice versa. So what we really need to set this up is two voltages. We need a voltage reference that stays put at a certain voltage, even though the battery's voltage is slowly diminishing, and then we need another voltage that kind of tracks that battery voltage and stays proportional to it. So the first thing we're going to do is set up this voltage reference, and again, there's several ways you can do this, but since we're talking about LEDs, I thought I'd use a couple of these cheap red LEDs that I have kicking around. An LED, when it's lit up, typically has a forward voltage of something around 2 volts, although that really does vary. These guys are about 1.9, I think. So I'm going to actually put 2 in series. And instead of a 2.2 k ohm resistor, I don't need these to light up. I just want to run a tiny trickle of current through them. So there we are, with a 100 k ohm resistor. And that means that the forward voltage of these is, well, it's about 1.75. So it's dropped slightly. But with 2 of them in series, we have a reference voltage of 3.5 volts. And check this out. If I drop the supply voltage from 9, 8, 7, 6, 5, even at 5 volts, we're still pretty close to the 3.5 volts it was. In fact, we've only dropped by about 1/10 of a volt. So these are perfectly stable enough to use as a reference voltage. So now I've got my op amp in, and it's powered to the 2 supply rails at pins 4 and pin 8, and you can see I've also connected this voltage reference to pin 2 and pin 5. Pin 2 is the inverting input of the first comparator, and pin 5 is the non-inverting input of the second comparator. What we want at pin 3 is a voltage that starts higher than the voltage reference, and then just as the battery gets to, say, 7.3 volts, somewhere between 7 and 7.5, let's call it 7.3, just as the battery gets to that voltage, it meets and crosses over our voltage reference, and that'll switch the output of this comparator from high and powering our green LED to low and switching that side of the LED off. So the way to do that is with a simple voltage divider, and honestly you can just do it with a couple of resistors and trial and error on your breadboard. The maths is very simple if you want to do it that way, or if you're lazy like me, you can use an online voltage divider calculator. Okay, I've got my voltage divider set up at pin 3. That's 110k, and that guy going to earth is the 100k. Now if I check the voltage on pin 1, which is the output of this first comparator, with this particular op amp, the TL062, it's not going to be fully 9 volts because it's not a rail-to-rail op amp, but this voltage will still be fine to power our LED. Now if I start dropping this power supply down, that's 7.6, 7.5, 7.4. When I get to 7.3 volts, that output, that first op amp's output drops low. So we can power the green side of this 2-color LED. So this is the LED I'm going to use. You can see, hopefully, it's got 3 legs. There are 2-color LEDs you can buy that have just 2 legs. They work a different way and they're not suitable for this circuit, but a 3-legged LED has a central cathode, and then if you power one side or the other, you get green or red. Slightly confusingly, some of these 3-legged LEDs, there's, oops, let me turn this power supply back up so we're switched on. There's red and there's green. So I'm going to power the green side. Slightly confusingly, some of these 3-legged LEDs are actually called 3-colored LEDs, and that's because, or tricolour LEDs, and that's because if you power both sides at once, they'll actually glow orange. Well, this particular one doesn't do that, but if you find one like that, it will still work in this circuit. This is quite a bright LED. I've been playing around with just how much current will get me to the brightness I need for the pedal, and I'm actually powering this with just with a 22k ohm resistor, so it really doesn't need much current, and that's plenty bright enough, I think. So again, if I start dropping my power supply down, there's 7.6, 7.5, 7.4, and at 7.3 the LED of course switches off. At that point we need to do a couple of things. The first is to connect the output of pin 1, which of course is swung low, to the inverting input of this other op amp, and you'll notice that the voltage reference is on this op amp is connected to the non-inverting input. So this is actually what's known as an inverting comparator. So this will actually will work in the opposite way to the first one, and when this drops below our voltage reference, then its output will swing high, and of course we just use that to power the red side of the LED. So I'm going to put this 100k ohm resistor in, if I can get the right one. By the way, I've been switching the power supply off every time I add parts. It's very easy to brush legs and stuff on these breadboards, and you can short things out if you're not that careful. So pin 1 to pin 6 with my 100k ohm resistor, and I'm just going to hook up this red LED resistor. Again, I was messing around with it before. The red side's not quite as bright as the green side, so for this LED I'm going to use a 10k resistor for the red side. So now if I switch the power supply on again, there's 8 volts, 7.6, 7.5, 7.4, and at 7.3 the other comparator goes high as the first comparator goes low, and we can power the red LED. There is just one more element to this circuit that bears some explanation, and that is this high value resistor here, R3. This is feedback that creates just the tiniest amount of hysteresis in the way this divided voltage at pin 3 actually changes. It will slightly change the actual point at which the circuit switches, but it creates, I guess, kind of a stronger switching action and pulls the comparator through that switching region where a changing load on the battery could cause problems. So there you go. It's a pretty simple circuit. It's great fun to play around with these sort of things on the breadboard. I've actually just found another op amp that would work as well in my parts bins. It's an LT1495. I've got no idea why I have it, but it looks like a very low current op amp, and it does actually swing rail to rail, so I might use that one instead. As always, I'll put a PDF on my website with the schematic, as well as this little stripboard layout I've produced. It's once again, I've crammed all the parts together. There's a couple of resistors standing up on their ends, and there's also a few sort of diagonal jumpers that actually have to go underneath the IC socket. But I mean, I've got plenty of room in this pedal, but you won't always have that luxury. So I have made this as small as really feasible. It's only going to be about an inch wide. And of course, here's the bottom view as well. So I guess I better get on and put this little project together. Okay, I'm back in the workshop today. I've got to finish off this 2-color status light project. I've already tested my little circuit board. It worked just as it did on the breadboard, so I've gone ahead and put some heat shrink on there. I've also found a place in the pedal itself where to mount it, and with that in mind, I've made the wires to the LED an appropriate length. I've also drilled a hole for the LED. It's a 3mm hole because I like to just mount the LED straight through the hole with just a drop of hot glue from behind. You can get mounting rings for LEDs and they work just fine, but I kind of prefer the cleaner look that gluing it gives. The next thing I have to do is mount my new switch. There is a slight problem. The new switch, these blue 3-pole switches, are about 4mm shorter than the original switch. That, of course, wouldn't normally be an issue in a regular pedal, but with the Crybaby, the height of that switch is kind of critical, so that you can just actuate the switch with just a little bit of extra pressure when the pedal is all the way forward. The original switch was mounted with a couple of washers, and these totaled to about 3mm, 3.5mm, and I could possibly get away with just leaving them out with my new switch, although I think I'd have to push really hard to get it to switch, and also without a shake-proof washer, which is what this little guy is, the switch will tend to loosen off over time. But instead, what I'm going to do, there's a piece of felt under this treadle, and it's almost worn right through. In fact, where the switch hits it, it's kind of completely flat. So I'm actually going to go ahead and replace the felt that's under the treadle. I've got these felt polishing wheels for my Dremel, so I'm going to use one of those. It will easily make up the difference in its thickness. It also seems to be a slightly harder type of felt as well, so I guess I just have to get this treadle off. So the first thing I have to do is remove this little nylon stopper so I can pull this rack away from the pot. The next thing I have to do is to remove this axle. It's from memory, it's been a while, but I think it's knurled on this flat end, and then at this other end it's actually chamfered. So I think I can just tap it out from the chamfered side. There we go. I should be able to pick that up with a chisel, I'd say. There we go. Yeah, that's completely worn out, that thing. I'm going to get in there with some solvents, I think, to clean up that residual glue. Cut that flat on a slight angle so I can get that in. Nicely like that. I've looked through my glues. There's quite a few things that'll do this. I think with super glue you might find that the felt will just wick up the super glue, and it's not going to work too well. But I actually have some contact adhesive which is ideal for this. So there we go. Let's put this pedal back together. Now this is like spring steel, and there's actually a little bit of tension on this, so I'm not sure if you can see through the hole there. I'm going to have to find a way of lifting this slightly as I push the axle back through. Okay, I think I'm just going to try and lever that up like that. There we go, and get the axle going. Okay, I've got my little circuit all installed. I've got my earth wire connected up as well as my 9-volt wire. I've got the switch in place and adjusted so that it clicks with just that little bit of extra pressure at the front end there. Just have one more wire to hook up, and that is this central wire from the LED, which is the common cathode between the red and green sides. So really all I have to do is work out which of these two switch lugs on my third spare switch pole are connected to earth when the pedal effect is on. There was one thing I was going to say, and that's a little top tip with these type of jacks. It's actually quite fiddly to get these lined up and threaded correctly. You can cross thread them really easily. Little top tip is to use a number 2 Phillips screwdriver, and you can thread the bushing on, and that will keep it all lined up as you get it threaded, or at least get the thread started. There's a pretty easy way to work out whether the pedal is in or out, or the effect is in or out, and that is simply to switch the pedal on. I'll just use an open jack, and I'll plug it into my amp. Turn it up. Okay, so the effect is switched in. And now all I have to do is use the continuity test on my little multimeter. To see which of these lugs. Okay, it's the left side. So I just have to hook up the cathode to the left lug. And finally, I just have to install this little guy again. The trick with this, and I guess the trick if you ever replace the pot in your Crybaby, because they do wear out, is to roll the pot as far anti-clockwise. If you're looking at it from the top, you want to roll it as far anti-clockwise, and then bring the pedal down and engage the rack that way. That way you know that when the pedal is, whoops, let me try that again. That way you know that when the pedal is forward, the wah pot is as far into the bright end of its travel, or the bright sound of its travel. And that's because with a Crybaby, only about, I think about 2/3 of the pot's actual sweep is used with the filter. So the way it's designed. So that's the trick. So let me get this out of the way. Just got to get this washer underneath the circuit board, which is a bit tricky. Otherwise, I think if I screwed it down from above, it would actually pull on the circuit board, and kind of you risk cracking the circuit board, which is not ideal. So there you go, there's my 18-volt Crybaby pedal, and I can run it on a 9-volt supply, and I also can keep an eye on the battery's condition with the status light. If I put in a good 9-volt battery, just switch this guy on, there we go, it's green. But if I plug in this old tired battery, which I think measured to about 6.5 volts or something, and try that, well, you can see the status light's now red. So there you go, the pedal's all done, ready to be put back into service. There was a couple of things I didn't film by way of servicing, I guess you'd call it. First thing I did was to remove all the gummy glue that was left behind from the previous owner's Velcro. You can usually just rub that off with some solvents. I often use white spirit. This is also known as dry cleaning fluid. I think in America they call this stuff mineral spirits. I might be wrong there, but it's what you thin oil-based paints with. That worked quite well for that. I've also put this on the bench with some scrap timber and a few clamps, just to flatten it out. These get very buckled and bent and so on, so it's nice and flat now. The other main thing I did was just to glue up some cracks in this little battery holder. I used one of my favourite adhesives for that, this stuff. It's called Loctite 480. It's a Ca glue or cyanoacrylate glue, but unlike regular super glue, which would just probably break, I would think, pretty much straight away, because these move and super glue is really brittle. Unlike that, this has a plasticizer in it, so it dries kind of like hard plastic. Works very well for those sort of things. It's also black, which is nice for ebony fretboards. You can actually use it as a drop fill in ebony fretboards or bridges or whatever on acoustics. I believe the guys that recone speakers use this on dust caps, and maybe some other jobs in and around that profession. I've never done that, but I believe they use something like that. I might be wrong. So there you go. I hope you enjoyed the video. I'll put the schematic and the little strip board layout on a PDF on my website, so take a minute to check it out. Try it in your next pedal build, especially if it's a pedal that you plan to use with batteries. Personally, I use pedals on batteries almost all the time. I don't really have a regular pedal board as such, so I'm often using pedals on batteries, so it's pretty handy. I hope you enjoyed the video, and thanks for watching. Please consider subscribing to the channel if you've found that interesting, and I will see you next time.